and another function is given, that is x square by 3 plus ax plus bx square. Okay, a not equals to 2b have a common extreme point. These two functions are having common extreme points. Okay, that means the maxima, minima, that is same, right? Right?
Yes, ma'am.
Yes,
Yeah.
ma'am.
So when you will solve the first function, I mean, you will be finding f dash x for getting the critical point, right? Here you will be solving g dash x is equals to 0 for getting the critical point. Are you understanding? Both the critical point will be same. Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay, because it says the common extreme points they are having. That means the x value which we are going to obtain from there, same x value we are going to get from here. Then only, okay, then after that we'll be checking the maxima and minima, we'll be getting it same. So we can compare. We can say that f dash x over there will be equals to g dash x over here. Let's do it. So if we will take f dash x, it will be twice x over 3, right? Plus
Yes,
2b
ma'am.
plus 2ax by 2. And what about g dash x? It will be twice x by 3. Okay, plus a plus 2bx, right?
Yes, ma'am.
We can see this twice x by 3 and twice x by 3 gone. 2b is there, a is there. Here 2 gone. Here 2bx was there. Yeah, just 2bx was there. So if we will take, okay, 2bx minus ax, okay, and then this, if you want to take this a plus 2b also on this side, or maybe if you are taking this twice b minus a on this side, what are we going to get? Can you see we are getting x value as a 1? Yes or no?
Yes,
And here
Yes,
ma'am.
also it is written that a is not 2b. It makes sense. Okay, a and 2b are
Yes,
not,
ma'am.
okay, then it will be 0, so it is not 0. Okay, a and 2b are not same, it is, okay, another number, and yeah, we can cancel them. We are getting x as a 1, getting it?
yes, ma'am.
We ended up getting x as a 1, and then we are supposed to find a plus 2b plus 7. A plus 2b plus 7 we need to find. Do we know a? No. Do we know 2b or just b? No. Okay, so we need to find a and b value from here. Are you getting it?
Yes, ma'am.
Ma'am.
Okay, this x equals to 1 we have obtained from here. This is like, can we say f dash 1 will be 0? Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay, if we will substitute this 1 over there in f dash x, our f dash x was we can write it was 2x by 3 plus 2b plus 2ax, that means just ax. Here if we will substitute 1 at the place of x, we are going to get 2 by 3, okay, is equals to 0, of course, plus 2b plus a is equals to 0. So can you see 2b plus a directly we are getting over here?
Yes, ma'am.
This value we will substitute over here. We don't have to think about finding, okay, just taking the same this one in the second g dash 1 and then just comparing it with 0, directly we ended up getting the value of 2b plus a, that is negative 2 by 3. Okay, and then we can just substitute over here negative 2 by 3 plus 7, and we will be getting the final answer. Got it?
Yes.
Yes, ma'am.
Concept is clear, Meera and Upasna?
Yes, ma'am.
Yes, ma'am.
Okay, so this concept we need to use for this question, which is nothing new. Okay, you have solved not exactly like this question, but these terminologies, these concepts are clear to you. Okay, so we are using it over here. Now, one more thing I must add, the same type of question. Okay, here in this, in the question, no, when you will see question bank, sometime the coefficients Okay, the numbers in front of x square, it will be like misprinted or here and there. So fundamental, like the concept which we need to use for this type of question, that is clear to you?
Yes, ma'am.
Okay, so even if the numbers, the coefficient are here and there, you just need to do it this way. That's it. Next, let a function is given. Okay, a function is given because one day I was going through few questions from a question bank and I found that few coefficients are wrong. So here 4 is wrong. Instead of 4, it will be 5 maybe or 6. Accordingly, the options are given. That's what I'm trying to tell you. Making sense?
Yes, ma'am.
Yeah.
Yes, ma'am.
So, but you just need to understand that logic, what logic we are using for this type of question. So yeah, let f of x is equals to a function is given. Okay, where x can be any real number. Then which of the following statement are true? Which statement are true? Here P statement P is given, then Q is given, and then you can see after this one R is also given. Okay, so P says that x equals to 0 is a point of local minima. You can already see the function. Okay, and P says that x equals to 0 is the point of local minima of f. So let's find first f dash x. Since our function, okay, we can clearly see, we will be quite careful while finding f dash x. For checking local minima, first we have to find f dash x. Yes or no?
Yes, ma'am.
Yes,
Okay,
ma'am.
find f dash x. This looks like a to the power x to you. Yes or no?
Yes, ma'am.
Yes, ma'am.
What is the derivative of a to the power x? Yes, Mira and Upasna. Is it a to the power x log e base a? I mean
Yes,
log
ma'am.
like this. Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay. So f dash x, a to the power x. Our a is this 3. Power as it is, we will copy paste. Log 3 base e. Clear? And yeah, this
Yes,
is not x. So by chain rule, we again have to do the derivative of this x square minus 2 cube plus 4. Yes or no?
yes, ma'am.
Yes.
Okay. So let's do it. 3 x square minus 2 whole square. But again, this x square minus 2, we need to do that is 2x. Is it making sense?
Yes, ma'am.
Okay, so we have just applied chain rule for finding f dash x, and we can see clearly, okay, our f dash x is huge. Let's collect the constants from here. So this is a constant. It's a constant. This is a constant. This 2 is a constant. Anything else? No. So we are having 3 2 times 6 log 3 base e. Okay, and then just write the other variables over here. That is 3 x square minus 3 whole cube plus 4. Okay, here we are having multiplied with this x square minus 2 whole square. Any confusion so far?
No, ma'am.
Okay, and we have to check. We have to check whether this x equals to 0 is the point of local minima or not. Okay, local minima means we understand. Already, if we want to check whether it is a critical point or not, okay, we can check by substituting x as a 0, right? Right?
Yes, ma'am.
So you can see into x is there. So we understand once we will put 0 over here, everything will become 0. And yeah, it can be the critical point, right?
Yes, ma'am.
Okay, one more thing. Is it a local minima? Okay, local minima means what? Minima means the function is first negative, then positive, or positive, then negative. Yes. First decreasing and then increasing, or increasing and then decreasing. First decreasing and then increasing. Yes or no? That is only minima, right?
Yes, ma'am.
Okay, if you get confused, please take it. First decreasing and then increasing, and yeah, it looks like minima. Okay, so we get minima in such situation. So we can check that on the left of 0, is it negative? On the right of 0, is it positive? So without even going ahead, we can say, yeah, the first statement is correct. Getting it?
Yes, ma'am.
Okay, so if you will take towards the left of 0, any negative numbers, let's say -1. Okay, so constant is constant. We don't have to think about that. Okay, next, if we will be checking for this part, 3x to the power, you can check that whatever you will take x, a negative number, a positive number, eventually it will give you a positive answer, right?
Yes.
Okay, here x we are taking -1, and here is square is there. So can you see we are getting negative completely? Yes or no?
Yes, ma'am.
Yes, ma'am.
Getting it? We don't have to do anything, but carefully we have to analyze. Now on the right of 0, suppose we are taking a number +1. So are you understanding this is +1, then the whole result is positive? And here it is minima. So P is correct, right? P is correct. Got it?
Yes, ma'am.
Yes, ma'am.
Q. Okay, whether Q is correct or not. Carefully, we will be doing the analysis. In Q, you will find a new terminology, and let me clear it now only because it's really simple. So if x equals to √2 is a point of inflection of f, point of inflection. Okay, we get this point of inflection when our graph looks like this. Okay, the graph is like this, and all of sudden it has taken the turn like this. So can you see it was this like downward, and then it has gone upward. Can you see?
Yes, ma'am.
Yes.
Okay, in such scenario we get the point of inflection. If I am drawing the tangent over here, okay, the tangent over here, and the tangent we will draw over here, so both will collide at a point, and which is called point of inflection. So basically point of inflection occurs when the graph is this. Okay, we call it downward, concave downward, and then upward. So the graph is downward and then upward, or maybe first upward and then downward. So this point will give you the point of inflection, the moment it is taking the turn. Getting it?
Yes, ma'am.
Yes.
Yes, that's called point of inflection. Now for checking point of inflection, we have to first find f double dash x. Anytime we have to find f double dash x. Okay, and we have to check that f double dash x equals to 0. The way you find the critical point, same process we have to do for checking the point of inflection. You have to find f double dash x is equals to 0. You have to set the equation. From there you will be getting the x value. You have to locate it on the real line, those x values, and then you have to check in which interval. If it is negative to positive, then you will say, yeah, this is point of inflection. If it is positive to negative, you are checking f double dash. Okay, everything is involved over here with f double dash. The first derivative test, you can, whatever process you do, everything we are doing for point of inflection, but with f double dash x. Okay, if it is negative, f double dash x. If it is negative to positive, yeah, this is point of inflection. Or maybe if it is positive to negative, yeah, this is point of inflection. If it is negative to negative, we don't have any point of inflection. If it is positive to positive, we don't have any point of inflection. Got it?
Yes, ma'am.
So everything you use for first derivative test, we have to do for do with f double dash x for checking point of inflection. Okay, if this much is clear to you, then we can check the next part, because everything in your syllabus is from, like, most of the everything, I can say 85%, okay, is from your syllabus. Few things, few terminologies are here and there which you have not learned, okay, and I'll be taking it in between questions. So x equals to root 2 is a point of inflection. So now you understand we have to check f double dash x as well. Yes or no?
Yes, ma'am.
Yes,
Okay.
ma'am.
Let's check f double dash x. It will, okay. We have to find it carefully. So constant will remain as it is. This was f dash x. In f double dash x, okay, I am writing it as a constant. Constant will remain as it is. We have to work on the u into v, okay, the product. So the first one, derivative, that means 3. Again, we'll be repeating the same process. A to the power x will be a to the power x log a base e. And then we have to do the multiplication as well. So I'm writing it. We'll be having 3 x square minus 3 whole square into 2x. Just the u dash we have found. We will copy paste as it is. And then v dash. Okay. So when we will do the derivative of this one, we will be getting, you can do the multiplication. Okay, x square will be x to the power 4, this will be just 4, and this will be minus 2x square. Outside x is there, you can multiply it. So basically you will be getting x to the power 5 minus 2x cube plus 4x. Yes or no?
Yes.
Yes.
Okay, it will be better to do derivative like this, or maybe you can still apply the product rule over there. So let's do it. So v dash will be 5x to the power 4 minus 6x square plus 4. This is our v dash. And what about u? We will copy paste u as it is. 3x square minus 3 whole cube plus 4. Now again we will collect all the constant and we will just keep it with our constant. So again this is constant, this is constant, this is constant, but okay, this is from the first term. Okay, from the first term we are having. So now taking out common is not possible. One thing which we can keep it out is this one, right? Right?
Yes, ma'am.
Let's take it out completely along with the constant which c I'm writing. So 3 to the power x square minus 3 whole cube plus 4. And then we are left with this log 3 we are having base c, and that multiplied with, okay, this I'm writing for now as it is. Okay, if we will need 3 2 times 6, wait, x square minus 3 whole square, and the other curly bracket is still we are having, that is x square minus 2 whole square. I must take a rectangular bracket, and plus just this 5x to the power 4 minus 6x square plus 4. Any confusion so far, Meera and Upasna?
No,
No, ma'am.
Okay, we have to check whether this root 2 is a point of inflection or not. So root 2 must give us, like, f double dash x must be 0 at root 2, right? Right?
Yes, ma'am.
yes.
Let's check it. So if we will take root 2 over here, okay, here root 2 square will be just 2 minus 3, okay, whole square. Here we must root 2. Root 2 square will be just 2 minus 2. Can you see we are getting 0 the first term?
Yes, ma'am.
The next term, if we will take root 2 over here, so root 2 to the power 4 will be just 4, right? If we will take root 2 square over here, it is just 2. So 20. Okay, and here we are getting minus 12, and this is 4. Just 4, right? Are we missing anything? We must get the other term as well, 0. Okay, so 5x to the power 4 minus 6x square plus 4. Okay, here also 0 must come. If it is point of inflection, then here also we must get 0. Okay, and for this particular question, we need to check over here the simplification, or we need to check the number. Okay, because so many time I have seen these numbers over here. Okay, we need to change. So you just understand the logic over here which we are using. This part will also come out as a 0. Okay, and you will find that yeah, root 2 is a point of inflection. Getting it?
Yes, ma'am.
Yes, ma'am.
Okay, now the next thing, that r, if f dash is increasing, one more thing, that like towards the one of the side of root 2, is it negative, is it positive over here, or is it positive over here and negative over here? See, you don't have to do the calculation, you just have to write the sign, that from the first part, are you going to get a positive sign or negative sign? From the second part, you are going to get a positive. In general, the complete will be positive or negative. Only this much you have to get the idea, keeping the constants aside. Okay, so yeah, root 2, f double dash root 2 is 0. That is giving us the hint that yeah, root 2 can be the point of inflection. And if we will be getting minus to plus or plus to minus by taking any test point you can consider on the left of the root 2. Root 2 value is 1.4, 1 something. So towards the left you can take 0, right?
Yes,
Right?
ma'am.
And
Yes,
towards the right you can take any number 2. Okay, and again I'm saying you don't have to do the calculation, you just have to check positive to negative, negative to positive. If this way we are getting, then yeah, root 2 is a point of inflection. So here we will be getting root 2 as a point of inflection. Now the next one, if r, another condition which is given, that f dash is increasing for x greater than root 2. F dash is increasing. How we check increasing, decreasing? So suppose I'm locating x greater than root 2. Suppose root 2 I am locating over here. Okay, and we are checking on the right of root 2. Okay, and f dash. So already f dash we are having over here, right? This is our f dash, right? We can check here if we will take a number towards the right of root 2.
yes, ma'am.
You can think about taking, suppose, 2. Okay, 2. Okay, if f dash x is greater than 0, let's think about it. If you will take 2, so 3 to the power negative number, positive number, it will not impact. We just have to check the curly bracket. If you are taking x as a 2, if you are taking x as a 2, this bracket is whole square. Can you see we are going to get a positive result?
Yes, ma'am.
Okay, and we
Yes, ma'am.
can see that yeah, okay, f dash is increasing for x greater than root 2. Are you understanding how we are doing these all things without even solving and without even thinking about solving it? Yeah,
Yes,
derivatives
ma'am.
are found, that was mandatory. So here PQR all will be true. Concept is clear to both of you, Meera and Upasna.
Yes, ma'am.
Yes, ma'am.
Okay, this is how we'll be checking it. Next, just a moment, let me share it. The function f of x is equals to x e to the power x 1 minus x. Okay, we are having f of x as x e to the power x 1 minus x. Okay, here we have to say the function is increasing, decreasing, which interval. According to the option, we'll be checking. Okay, but first let's find f dash x. F dash x. Our f dash x is, okay, UV method we'll be using. So the first derivative of the first function, so that is just 1. We will be having x e to the power x 1 minus x plus, okay, first function as it is derivative of second function. So e to the power x will be e to the power x. But in chain rule, you have learned how to deal with this. So better to take it as a x minus x square, right? Right?
Yes, ma'am.
Okay, x minus x square will be 1 minus 2x into 1 minus 2x. Getting it?
Yes, ma'am.
Okay,
Yes,
this
ma'am.
is our f dash x. What we are trying to do over here, we are just trying to check increasing, decreasing. Okay, we can take out common factor e to the power x 1 minus x, and we will be left with 1 plus x 1 minus 2x. When you will set this is equals to 0, you understand e to the power anything. Okay, we cannot say compare it with 0, right? E to the power anything can't be 0. Okay, negative number, positive number. Getting it?
Yes,
Even
ma'am.
if you take e to the power 0, the result will.
Yes, ma'am.
Okay, so that we will not compare. We will compare this curly bracket. Okay, that this 1 plus this x minus 2x square. This is equals to 0. And from here, we will try finding x value. Let's do splitting the middle term and factorization over here. So 2, 1 times 2. I believe 2 and 1 will work. So minus 2x square plus 2x minus x plus 1. That means minus 2x we will take out common. We'll be having x minus 1. Minus 1 we will take out common. So this is what we are having. Right? Mira and Upasna?
Yes, ma'am.
So basically, we got x value as a 1 and we got x value as a 1 by 2. Now from here only we need to check which one. Okay, just a moment. Just a moment. So from here only we need to check that the function is increasing in which interval, decreasing in which interval. Okay, we will be able to check our f dash x. We can already see over here. Let's continue. We can clearly see our f dash x over here. This one. Okay, this is our f dash x. And we understand whatever we will take in the power of e, that will not give us, okay, negative number. So yeah, we will be checking this curly bracket basically. So towards the left of 1, if you will take 0, so we are going to get a positive result, right? So here it is increasing, right?
Yes.
Yes, ma'am.
If we will take in between 1 to 1 by 2, okay, why I have taken like this? Wait, it was not negative 1 by 2, it was just half, and it was 1. Like this we'll be taking, right? Right?
Yes.
Okay, half means 0.5. It's not minus half. So yeah, towards the left of 1 by 2, 0, right? 0 we can think. And yeah, we are getting positive, right?
Yes, ma'am.
Yes.
Okay, between 1 by 2 to 1, if we will take. Okay, suppose 1 by 2 means 0.5. If you will take any number in between, suppose 0.8, we don't have to do the calculation, we just have to get a idea. So this will be 1, okay, and here we'll be having 0.8. Here we'll be having 1 minus 0.8 into 2 will be 0.16, right? No, 1.6. 1.6. 1.6. So we can see here we are getting negative number. Okay, 1, yeah, negative. Okay, and 1 added with that. So let's do the simplification. It's not that tough. We are going to get 0.8 multiplied with a negative. What negative? 0.6. Okay, and 1 added with that. This is what we'll be getting, right? Right? Right,
Yes,
Miran?
ma'am. Yes,
Which is, you can see it's a positive, right?
yes, ma'am.
And the last one. Beyond this one, you can think about 2, 3, anything. Suppose we are thinking about 2. Okay, so 2 times 4, 1 minus 4 is -3. Okay, -3 into 2. Here we are getting negative. Now let's check the option. The function this is increasing in this. -1/2 we don't even have got. Okay, decreasing in 1/2 to 2. 2 we don't have a critical point. Increasing in -1 to -1/2. Increasing in -1 to -1/2. -1 we also don't have. Wait. And decreasing in -1/2 to 1/2. Again. Okay, in this book, no, most of the question I can see the options are like this only. Here, main fundamental is the question. Somewhere the question, the typing and everything is there. First, let me check the roots we have found, the critical points. That is correct or not? Yeah, we will be getting, wait. Here we will be getting excess of -1/2, right? Right? Are we? Minus
Yes,
2x
ma'am.
is equals to just 1. And x is equals to -1/2. Okay, it will be -1/2. It will not be 1/2, it will be -1/2. Be careful while doing this minute simplification. Okay, we are getting x equals to -1/2 and we have to take -1/2 over here. Okay, so 0 will not be the proper test point. We could have taken this -0.5 we are having. So you can take -1. Okay, remaining test points are correct, right? Here we can take 0, the middle one, and it still will be getting positive. The other one is right, the extreme left side. Okay, we can take the test point as a -1. If we will take the test point as a -1, we are having c 1 plus x 1 minus 2x. If you will take test point as a -1, okay, test point as a -1, so this will become positive. You will be having negative 1 minus 3 negative, right? So increasing is this interval, just this. Can you see?
Yes, ma'am.
Okay, so
Yes,
we
ma'am.
is increasing in -1/2 to 1. Now let me check that option is there or not. -1/2 to 1. Yeah, first option is there. Got it?
Yes, ma'am.
Okay, let's
Yes, ma'am.
move. This is how the very basic question, much more tougher question you have already solved. You just need to do it like this. Okay, from the whole question paper, first just scan the questions which you have already, the concepts you have learned, even though it will look like that how the function is defined or how exactly the question is framed, but okay, have patience and just read it carefully. Definitely you will be able to solve it. Okay, now the next one, the sum of absolute maximum and absolute minimum value. You all understand what is absolute maximum and absolute minimum, right, Meera and Upasna?
Yes, ma'am.
Okay, so here absolute maximum and absolute minimum we have to find for the function f of x is equals to tan inverse. Okay, sin x minus cos x. Let's find. First, we need to find the critical point. The process is find the critical point and just that. Okay, then take this interval 0 to pi and whatever critical point you have found, find the function's value at all this point. If absolute maximum minimum is there, it will be there either on the critical point or this interval, right?
Yes,
Yes,
ma'am.
ma'am.
That is the process. Let's do it. So we will be finding f dash x first. What is f of x? Let's do it carefully. So here tan inverse sin x minus cos x is there. Tan inverse derivative is 1 by 1 plus x square, right?
Yes, ma'am.
Yes, ma'am.
Okay, then by chain rule we have to do it again. Sin x minus cos x, again we have to do it. That means sin x will be just cos x and cos x will be minus sin x, that is plus. Yes or no?
Yes, ma'am.
Yes, ma'am.
So this is what we are getting as f dash x. Okay, if we will set it equals to 0, equals to 0, then we understand the denominator we can't say that will be 0. Okay, that is not possible. We can only say that the numerator can be 0, right?
Yes.
That means we are getting
Yes,
cos
ma'am.
x is equals to minus sin x. That means we can say that tan x is equals to minus 1, right?
Yes.
Okay, now we have to check, keeping in mind x, we are bound to this interval 0 to pi. So in this interval, are we getting any x? So tan x is equals to negative in second quadrant. Okay, tan is negative, and in fourth also. So 0 to pi means second quadrant. We can think about, we can say tan of pi minus pi by 4, right? Yes or no?
Yes, ma'am.
Since x is 4 pi minus pi, that is 3 pi by 4, right?
Yes, ma'am.
Okay, we ended up getting the critical point, and yeah, we will be checking absolute maxima, absolute minima. So we will be finding f of 0, we will be finding f of pi, we will be finding f of 3 pi by 4. Now here is a catch. Okay, let's find it quickly. So f of 0 is this tan inverse sine 0 is 0 and cos 0 is 1. So basically we are going to get f of 0 as a tan inverse minus 1, right?
Yes.
Yes, ma'am.
Okay, and we can say it will be minus pi by 4, right?
Yes, ma'am.
Okay, f of this pi is C. This interval is fine, but the answer we are getting, that we are keeping in mind the inverse trigonometric function, that concept. Okay, that what will be the range, the possible output will lie in the principal range, that we are thinking. Getting it?
Yes.
Yeah.
Yes,
So we will take pi. So sine pi is 0 and cos pi is negative 1. So we will be getting minus of minus 1 tan inverse 1. That means we are going to get pi by 4, right?
Yes.
yes, ma'am.
Okay, and 3 pi by 4 if we will be taking, so sine 3 pi by 4, that means just pi minus pi by 4, sine pi by 4, that means just 1 by root 2, right?
Yes,
Right. And cos 3 pi by 4 will be, cos 3 pi by 4 will be cos pi minus pi by 4, that means minus cos pi by 4, right?
Yes.
That means here already minus sign is there. Cos pi by 4 value is 1 by root 2. So can we say 1 by root 2 plus 1 by root 2? Can we?
Yes.
Getting it, Meera and Upasna?
Yes.
yes,
Okay, so we are going to get 2 by root 2. Okay, basically we are going to get 2 by root 2. We can cancel them out and we can say it is nothing but just root 2. So are we having tan inverse root 2 like this? Do we know the value? No. Okay, if we were allowed to use the scientific calculator, then we could have taken out the value, but not now. Okay, so we will be writing, we are getting tan inverse root 2. Is it making sense?
Yes.
yes, ma'am.
Okay, now we understand. Okay, the tan is increasing function. Okay, tan is increasing function. So among this, which one is absolute maximum, which one is absolute minimum? Let's check it. So for reference, tan 0 is 0. Okay, then tan 30 degrees, what is the value for tan 30?
1 by root 3.
1 by root 3. Then tan 45 is just 1. Then tan 60 is just root 3. So can you see? Okay, the value is also increasing, and the graph also is known to you. It is just going up till infinity, right?
Yes, ma'am.
Okay, so tan is increasing function. If we will take this root 2, this means 1.4, this pi by minus pi by 4 means minus 45, pi by 4 means 45, and root 2 means 1.4, 1 something. So can we say it will be greater than this 45 degree? Bigger angle, bigger value, yes or no?
Yes, ma'am.
Okay, we can say, because we have to analyze absolute maxima and absolute minima, we must understand here which one is the maximum, which one is the least. Okay, so the sum of absolute maximum and absolute minimum, least is minus pi by 4. Okay, this is absolute minimum, right? And absolute maximum is this one, can we say?
Yes, ma'am.
Yes.
Clear? Let's check the option. Is it there? So tan inverse 1 by root 2 minus 4 minus pi by 4. 1 by root 2. But we have got just tan inverse root 2. Can you see? Yes or no?
Yes, ma'am.
Okay, so this is a catch over here. You can see the other options. We will be taking a triangle over here. Okay, and we are thinking that if tan inverse 1 by root 2, these things you must have learned in inverse trigonometric function. Tan alpha is 1 by root 2. Okay, that means opposite one we can say, and adjacent root 2 we can say. So if we are having a right angle triangle, right angle at B, and if this angle is alpha, opposite we can represent as 1, and adjacent we can represent with root 2. And here one of the option is having cos also, so we are just trying to check. So cos alpha can be written as adjacent over hypotenuse. Hypotenuse will be able to find root 2 square is just 2, and this is so root 3. So adjacent over hypotenuse. Okay, so here adjacent is root 2, right? Or 1. Wait, tan alpha is 1 by root 2. Tan formula is opposite over adjacent. Here opposite we have marked as a 1, and adjacent we have taken as a root 2. Okay, and what about the option? Fine, let's check it. So if we will be taking cos alpha, it is adjacent side over hypotenuse, right?
Yes, ma'am.
Nobody
Yes.
said that it was tan just root 2, not 1 by root 2, right? Right? Right?
Yes, ma'am.
Yes, ma'am.
Okay, so tan alpha is root 2. And here we will be having again same opposite over adjacent. Opposite is root 2 and adjacent is 1. Okay, we will be doing the calculation for the hypotenuse, and we will be getting, yeah, root 3. Cos is adjacent over hypotenuse. Our adjacent side is 1 and hypotenuse is root 3. Alpha will be cos inverse 1 by root 3, right?
Yes, ma'am.
Instead of tan inverse root 2, we can also write it as cos inverse 1 by root 3, right?
Yes, ma'am.
Okay,
Yes, ma'am.
now we have to take the summation of the maxima, absolute maxima and absolute minima. So cos inverse 1 by root 3 minus pi by 4, because when we will add this negative. So this is what we'll be getting, the third option. Yes or no?
Yes, ma'am.
Clear?
Yes, ma'am.
Okay, so finding absolute minimum maximum was not a big deal, but then option was confusing. But this type of scenario again you have faced in inverse trigonometric function. Yes or no?
Yes.
Okay, now the next question. Suppose we are having piecewise defined function. Let f of x is this one. X cube minus x square plus 10x minus 7, where x is, okay, when x is smaller or equals to 1. And it is negative 2x plus this when x is bigger than 1. This is how the function is piecewise defined. then the set of all possible value of b for which f of x has maximum value at x equals to 1. This f of x has maximum value. Okay, so for checking maximum value, okay, first we need to find the critical point, right?
Yes, ma'am.
Then maybe first derivative test or second derivative test will help us, right?
Yes.
Yes, ma'am.
Okay, but here the function is piecewise defined function. Okay, piecewise defined function we are having. How to deal with this type of function? So if f of x has maximum value at x equals to 1, maximum at x equals to 1, maximum. Okay, so this is how we can think about the graph, right? We can
Yes,
say
ma'am.
that the function's value at f of 1 and the function's value f at 1 plus, that means, okay, towards the right of 1, which you have learned in the limit concept. Okay, this value must be smaller than or equals to f of 1, yes or no? Because the f of 1 is the highest, so we can see clearly, okay, on the right side it must be smaller, right? The y value output, right?
Yes, ma'am.
Then only it has to be the max, right? So if we understand this scenario, then we will be using the limit concept. We will be comparing, we will be creating an inequality that f of 1 must be smaller or equals to, okay, towards the right side, the right side limit x tends to 1, but the right side 1 plus f of x. Okay, and accordingly we will be choosing the function. So let's take it. F of 1 will be, here equality sign is there. Okay, and you are used to see getting such situation in continuity differentiability chapter. Okay, so many examples you have done like this. So when f of 1 we are calculating, of course we will be taking this one, right?
Yes, ma'am.
Okay, so it will be 1 cube. Let's do it carefully. It will be 1 cube minus 1 square plus 10 minus 7. That means 0, 10 minus 7 is 3. Are we getting 3? Please check it. At x equals to 1. We are, right?
Yes, ma'am. Yes.
Okay, we are getting 3. Let's write it.
Yes, ma'am.
3 over here, smaller or equals to. Now limit x is approaching 1 towards from the right. From the right. So from the right, x is bigger than 1. We must use this function, right?
Yes.
Here we will put,
Yes, ma'am.
okay, limit x tends to 1 plus f of x will be, here we will substitute 1 at the place of x. That is the basic way of finding the limit, right?
Yes, ma'am.
Yes,
So we will substitute 1 over here. What are we going to get? Minus 2 plus log b square minus 4 and base is 2, right? Meera and Upasna.
yes, ma'am.
So let's compare it. Minus 2 plus log base is 2, b square minus 4. This is what we have created so far. Now we need to solve this inequality. So 2 will go to other side. 3 plus 2, 5. 5 is a smaller equals to log base 2 b square minus 4. So far, any confusion?
No, ma'am.
No, ma'am.
Okay. Now, whenever we are having this type of inequality where logarithm is involved, one thing we must write, that here b square minus 4 must be greater than 0, right? Another inequality we are creating by ourselves, right? Right?
Yes,
Okay, so b square must be greater than 4. Okay, or we can write it this way as well, b square b plus 2 b minus 2. That will give us more clarity. That means here the solution point will be, which will give us greater than 0 towards the left, towards the right, what? In between minus 2 and 2, Let me check. So if we will take 0, if we will take 0, no. Okay, this side and this side, are you getting it?
Yes, ma'am.
Is it so?
Yes.
Check it. Yeah, okay. So beyond this, okay, minus infinity minus 2 and 2 to 0, 2 to infinity. This is how we'll be getting equality. We will not take equality sign is not there. So close interval we will not be taking. Fine. So this is one of the condition which we have solved. Still we have to solve this inequality, right?
Yes, ma'am.
Yes, ma'am.
What we can do over here, if we will take it as, we understand that if log 2, like log base square minus 4 base 2 is equals to 5 will be there, we could have taken 2 to the power 5 is equals to b square minus 4, right? Logarithm to exponential form.
Yes, ma'am.
Okay, but how to use this concept over here, like where equality sign will be there, where equality, like which side we must change, right? Right. So let me take one example. Suppose we are having, let me create the example, just a second now. Is it making sense, Mira and Upasna? Can you see we have taken the exponent of 2 and the exponent of 2 over here?
Yes, ma'am.
Okay, then this one will be 1, right? We will just end up having x over here, right?
Yes, ma'am.
Yes, ma'am.
Okay, and x is smaller than 2 to the power 8. This way we don't have to get confused that where exactly we will substitute 8 and log, which side we will take which number, right?
Yes.
Yes, ma'am.
Okay, so if we will use the same logic over here, okay, here also whatever is there we are going to take as a power of 2, and there also whatever is there we are going to take as a power of 2. Okay, so exponent logarithm to exponent form is fine, but while solving the inequality we can treat it this way. Whatever is there we will taking it as a power of 2. Why 2? Because here, okay, 2 is there, that's why. And here also whatever is there we will take it as a power of 2. Okay, and this way the inequality sign will not change. We will be having everything as it is, smaller or equals to. Now we can say here we are left with b square minus 4, and here we are left with 2 to the power 5. Is it making sense?
Yes.
Yes.
Okay, so we can say here we are having b square greater or equals to 32 plus 4, that is 36. Okay, again you can do the same way, b square minus 36, that means b plus 6, b minus 6. And the solution, it is smaller or equals to 0 you are having. Wait, no. If you are taking it to other side, here you are having 0. Okay, getting it, Mira and Upasna. Okay, solution, the range for the solution will be, are you understanding, here minus 6, here plus 6. If you will take a number in
Yes.
between, okay, 0, so it is incorrect, right? So this way and this way you will be getting, right?
Yes, ma'am.
Minus infinity to minus 6 and 6 to 0, and yeah, not 0 infinity, and yeah, Equality sign is also there. So close interval, close interval. These two are the solution. But previously already you have one more condition. Okay, you have to take the union of this one and I mean the intersection of this one and this one. The common solution. Are you getting it?
Yes, ma'am.
Okay,
Yes,
so
ma'am.
representing the common solution, that solution also over here, minus infinity to minus 2. Okay, suppose here minus 2 is there. The other solution is representing minus infinity to minus 2 only. Okay, this side from here. And this one, 2 to infinity this side. So the common solution we are checking. So we can say this negative infinity to negative 2, right? And 2 to infinity, right? Right?
Yes, ma'am.
Okay, this will be our answer. Again, it is not there. Please check the common solution, okay, properly. This will be the fundamental which will be used over here. And yeah, again, I'm repeating in this book, so many questions I have seen there is a misprinting. So it could be that there is a misprinting of number or what